Let's have a look at the next section of the explain-ash output, which is called Parallel Worker Activity Overview based on ash. And like the previous section, this only shows up when parallel execution is involved. The idea of the section is quite similar to the previous one. It basically analyzes the activity on DFO tree level, but in this case here, this information is now on a more granular level, whereas this part here was on DFO tree. We now get here still the information organized by DFO tree, but now since we can extract the process information from active session history, it is now organized on DFO tree per process, and within each DFO tree these processes are then organized in these parallel slave sets. So each DFO tree, as I explained in the previous part, has either 2 or 1 sets, and therefore we can see here that this DFO tree number 1 consists of 2 sets, and therefore the processes are now organized here in set number 1 and set number 2, whereas the second DFO tree for this parallel execution plan only consists of a single parallel slave set, and therefore we only see this single set here. So this information here is again based on the active session history samples, which also means that if these processes here were not sampled at least once in the active session history, then they simply won't show up. So it can happen that you do not see all of the processes involved here in this overview. In principle, it corresponds to the processes found here in the overview. So since we have here found 6 processes, you will also see then find 6 here in this overview. Likewise 3 here, and you will find 3 here. So although you could have a degree like, let's say, 8, it could still be possible that you see in the active session history only 2 of them sampled. Then even with a degree of 8, you would only see 2 of them showing up here in this overview. And this information here on process level is pretty similar in general. The idea is pretty similar to what you get from the real-time signal monitoring report. If you analyze a parallel execution, then you have here this parallel tab on the detail pane, and then you see here the work performed on process level in the monitoring output. The main difference between these two is that this here is based on the additional monitoring instrumentation code. So this is what you also see in VDollars plan monitor and the corresponding views, whereas this information here from explain-ash is based on the active session history samples. So the data sources for these two are different. So this also explains that they do not show exactly the same information, although the sampling of course should be in the same ballpark than what the monitoring instrumentation shows. So the organization, as I said, is per DFO tree. So for each DFO tree you get the process information per slave set. You might wonder why this section here shows up with this null, or in more recent versions this is called NA, not applicable. This is for those active session history samples that could not be related to a DFO tree. How is this possible? The point is that the active session history does not directly contain an information about the DFO tree. What the active session history contains is the active plan line when the sampling took place. So this is what I will come to later here in this top active plan lines. So what we see in the active session history is the plan line that was active. So explain-ash uses this plan line and the execution plan information to derive which DFO tree this activity was about of this process. So, and since it's possible that sometimes samples show up in active session history for parallel processes that cannot be, according to the execution plan, related to any DFO tree, I show them in a separate section. We can confirm this here by looking at the top active plan lines. The top active plan line is 0 here, and if we look into the execution plan line 0 is this root node here of the execution plan. And this root node is not related to any DFO tree. The DFO trees start only here below, DFO tree 1 and 2 here in this case. So obviously there were samples for these processes that were showing this ID 0 for the execution plan line. Hence I show them here in a separate section just to make that here more clear and more obvious that you can end up with samples that of parallel processes that do not really belong to any of these DFO trees. Usually you shouldn't find too many of them, like here we just have one sample each with this execution plan line 0, but there are cases, for example, if you run into bugs with parsing where processes spend a lot of time in cursor mutex contention, like this cursor pin s wait on x for example, then you might even end up with more of these samples that might then even show up here with no plan line information at all, like plan line null would then show up here. But usually you don't see this section at all, or you should expect to see just a couple of samples, and the main activity should of course be here on DFO tree level. So for each process of each set, Explain-Ash then shows detailed information about the number of samples found, and then more details that can be derived from the active session history samples. One of the main points that this section allows to understand is how the work distribution on set level looks like. The idea is that in principle each set should have a similar amount of work per slave. So the amount of work should be distributed ideally evenly among these slaves per set. So as you can see here in this set, we have a quite good distribution of work. We have a quite good distribution of work here, but we can see here in this set that the distribution of work is clearly not really equal, because we have here only 13 samples for these two processes and 39 samples for this process here. And just to make this clear again, it doesn't matter whether you have a different distribution per set, so it's totally okay that maybe this set could show a completely different amount of work than this set. The goal is that within one set you end up with a similar amount of work per slave. So that's the idea. So this is okay that this set here is showing a different amount of work than this set and a different amount of work of this set, but what you should watch out for is that whether you see per slave set a similar amount of work per slave or not. So this here is an indication that something with the work distribution didn't work out very well. What you see here is these @ signs and this asterisk signs. Again, this is just a graphical representation of CPU activity and non-CPU activity. So you can see here that this graph in principle corresponds what you see here with the figures following, like 26 of these 39 samples where CPU activity, and 13 of these samples were non-CPU activity. So that's what this graph then here indicates, which means that we have roughly 67% of CPU activity, and likewise for the other processes as well. One important point that I should mention is that, as I've just explained, Explain-Ash requires the execution plan in order to derive this DFO tree information, and since this section is supposed to be grouped and organized by this DFO tree and set information, the execution plan is crucial in order to come up with this organization of the section. This means if the execution plan is missing, like in this example here where the execution plan could not be found, this also means that this section here then looks differently. You can see here that now this organization by DFO tree and set is missing, and we just get the overview on process level, which is still better than nothing. But the point is that you now cannot come up with this information whether the work distribution per set was good or not, because simply we do not have this set related information. So just to give you this information here, that this section can look differently. If the execution plan is missing, you won't have this organization by DFO tree and set. So this is just something to keep in mind, that when the execution plan cannot be found, this section looks differently. And also the previous section, this section here, which I talked about in the previous part of the tutorial, will simply be missing, because since it is about the DFO tree information, when the DFO tree cannot be determined, there is no point in showing this section. Therefore, when the execution plan is missing, this section here, you see here, it's simply not there, because there's no point in showing it. So what else can we say about this section? There is some more information that we, depending on the version of Oracle, in the most recent versions we have also PGA and temp related information. So we see here the maximum of PGA found in these samples for these processes. Here we can see quite similar PGA allocation per set per process, and also the maximum temp allocation, which is not that similar here in this case. This process here has allocated as a maximum allocation a little bit more than the other ones. These have a very similar allocation. And you have always to keep in mind this is based on the active session history samples, so it's not necessarily the real maximum value that was there during execution. Is just the maximum value that was found when the sampling took place. Then this section here is what I already mentioned, is about the top active plan lines per process. So what is the meaning here? This 29 and the parenthesis 8 means the plan line 29, and if we go to the execution plan, we could relate this to the execution plan, which is then this one here with the ID 29. For this execution plan 29, the process P000 was found to be active 8 times. This is the idea here with this number of samples in parentheses. And likewise, execution plan line 17, it was found to be active 5 times, and so on. So that is the idea here, that you see were the top active plan lines per process. And if you see here this ... this simply means that there were more than this top 3. In the configuration section of Explain-Ash, this is by default configured to show the top 3 top active plan lines. So there were more than 3 plan lines. This process was active on more than 3 different plan lines, hence this ... So you could configure, if you want to see here more of them, you can configure in the Explain-Ash configuration section that it shows then 4, 5 or whatever number of top active plan lines in this section here. And then we get the top activities. This is basically a more granular breakdown of this CPU and non-CPU activity information here. So in particular for those 13 non-CPU activity related samples, we would now see here what these were about. So we see here again these 26 CPU related samples, but also now these remaining non-CPU related samples, which were about direct path read temp and direct path write temp in this case. So and then finally, if you have a recent enough version of Oracle, we also get some let's say session statistics based information in this section here, which means that we get mainly information about the I/O that each process has performed, which is again a little bit similar to what you get here in the real-time SQL monitoring, but again just to keep in mind, this is based on the monitoring information and this is based on the sampling from the active session history. We can see then, for example, that these figures are not entirely the same. So we have here an I/O amount for this process P000 of 324 megabytes, whereas in the active session history sampling this only shows up with 311 megabytes. So these do not correspond always, although they should be in the same ballpark. So you see here 300 310, 820, and here 320 and 820. So it's not exactly the same, but it's in the same ballpark. Yeah, and we have here different figures like number of I/O requests, amount of I/O read and writes, and from 12C on we even have this buffer cache logical I/O information, read mem bytes here called, because it's only about what is about the buffer cache. This does not include direct path reads and writes. So this is only about the amount of data that was actually accessed via the buffer cache. And the same figures then I also show up here with this per second information. And if you wonder, here in this case we have a very similar amount of read and write requests, but the per second figure is pretty different. Then this comes from the fact that each active session history sample comes with a delta time information. So basically this delta time information tells us this accumulated session statistic information for what time period this was accumulated for. So this, according to the active session history, tells us although we have issued a quite similar amount of read requests as write requests, very likely the writes were over a much longer period than the reads, at least according to the requests, which we can also see here in the read and write per bytes per second. So we have here an average of 11 megabytes per second read, but only an average of 1.5 megabytes written per second. I've also added this I/O layer bytes information here, which is for non-exadata environments simply the sum of the reads and write amount. So doesn't really add much value for non-exadata environments, but for exadata environments this here could be quite different depending on the offload percentage and the decompression compression that took place on the cells. So it basically is the information about the number, the amount of bytes exchanged between the compute nodes and the cells, in case this is exadata, and hence is not necessarily the same as the sum of the read and write bytes on database level. So that's the reason why I have added this here for the exadata cases. And finally, we can also derive here, since we have the number of read requests and we have the amount of data, we can come up with average and middle values for the read request and write request sizes. So we see here this typical 250K for temp activity, temp reads and writes in this case here. And here we see a different pattern, like this 1 megabyte average IOs, which was probably not about temp activity. And also here we see that this process did something different in terms of write activity. The average and middle value was also close to 1 megabyte. So this is just something which is derived from this amount and sometimes can be helpful to spot certain patterns in the data. Yeah, that's pretty much it. What you get here on process level. And as I said, one of the main points here is to see this distribution of work here on set level. If we look on cross-instance parallel execution, so if multiple instances are involved, this section pretty much looks the same and still has the same layout. So the organization here is still on DFO tree and set level. So The only difference is now that we have this instance ID here information added, and you see here that this instance ID for the process names, I use this prefix so that it's clear if you look at the process name where this process comes from. So for the instance ID number 1, this process names will be prefixed with this 1, and for the instance ID 2 here the process names will be prefixed with this 2, and so on. I prefer this representation here where this information is still organized by DFO tree and set, and then we basically get here from all involved instances the processes per set shown, because it then still allows us to tell this information here whether we have a good distribution of work across these within these sets or not. In the real-time SQL monitoring, by default, the organization in this section looks a bit different if we have a cross-instance parallel execution, because it is per instance, which is also not bad, because we see then this basically this total amount of database time per instance, but it's not really helpful if we want to get an understanding of this work distribution, because now the different processes of the sets are here spread across these different sections, which is not really that helpful. But you can click on this show instance node information, and then you see here that now again we have this organization like we have in Explain-Ash. So now we have here this additional instance ID column, and the processes show up on set level. One thing that is also maybe helpful to point out, in the real-time SQL monitoring, for whatever reason, the DFO tree information is called parallel group. So if we have multiple DFO trees, then they will show up as parallel group 1 to n. I have no idea why Oracle has invented here another term for this DFO tree, and I think it's also the only place where the DFO tree is called parallel group. So that is probably more confusing than helpful, but you just have to keep in mind when you read here parallel group, then what is meant by this is parallel is meant DFO tree. So this corresponds to the DFO tree information here. You can also see here the case where we have activity sampled of the query coordinator, which in this case resides on instance ID number 1. And of course it can happen that the query coordinator is also sampled with activity. If there is, for instance, a section that is serial in the execution plan, then you will find corresponding samples that are executed by the query coordinator, or from 12c on you have this new PX selector or one slave distribution thing where also parallel slaves could execute serial parts. But the point I'm trying to make here is that if you have activity sampled of the query coordinator, then it will either show up when it can be related to a DFO tree within the DFO tree, but the set, since this is not about parallel slaves, there is no point in pointing out a set, therefore this is not applicable here. That's the reason why the set ID here shows up with this NA, and it would even be possible that this activity is also outside any DFO tree. Then again it would show up with this null in older versions, or in more recent versions with this NA, like in this report here would then show up in this section here when it cannot be related to any DFO tree. Yeah, and I think apart from that, this is pretty similar, I said, and it's also quite similar to what you see here in the real-time SQL monitoring output. But again, the most important point is that this is here based on the monitoring information, and this here is based on the active session history, which has the advantage, and this is the reason why I use this active session history as source here, of course, has the advantage that it's much longer available for analysis than the real-time SQL monitoring information. So if the monitoring information is gone, you no longer have the information here that you see here in the reports. In 12c, the top reports will be saved in the AWR repository, but in 11.2 they simply will be aged out of the memory pool, and therefore you don't no longer have this information, whereas this active session history information here is still available, even it can be then based on the samples in the AWR DBA hist active session history.